In section 7.5, we're going to be using proportional relationships. We're taking what you've done in the past with writing proportions and word problems and applying them to geometrical concepts which involve similarity, perimeter, and area ratios in this section. So we're first going to talk about indirect measurement. Indirect measurement is any method that uses formulas, similar figures, and/or proportions to measure an object. So why do we do this? Because rather than just measuring something directly, we can measure it indirectly. Like this tree that you see in this picture. You can't, unless you climb the tree, measure that tree. So we can measure it indirectly by using a proportion. So for example, number 1, a student wanted to find a height of a statue of a pineapple in Nambour, Australia. She measured the pineapple's shadow and her own shadow. The student's height is 5 feet 4 inches. What is the height of the pineapple? Now, really easy. I mean, you're going to look at this and go, well, we've done this before. This is a proportion. You're right, it is. The problem is that we can't actually use this because the dimensions are given in both feet and inches. So you must convert them to either all feet or all inches before doing any calculations. Well, what I'm going to do is just convert them all to inches. So I know that, let's do 2 feet. 2 feet would give me 24 inches over 8 feet 9 inches. Well, 8 feet 9 inches, that's 8 times 12 plus 9 inches, that's going to be 105 inches. And then the height of the girl, or the student, is 5 feet or 4 inches. So 5 times 12 plus 4, that gives me 64 inches, over x, which is the height of the pineapple. I then have to cross multiply. If you solve this, you're going to get the pineapple to be 280 inches. So you could say the answer is 280 inches, or 23 feet 4 inches if you converted it back to feet and inches. Now, a scale drawing represents an object as smaller than or larger than its actual size. The drawing scale is a ratio of any length in the drawing to the corresponding actual length. For example, on a map with a scale of 1 centimeter to 1,500 meters, 1 centimeter on the map represents 1,500 meters in actual distance. So the scale represents the ratio. So in example 2, the scale of this map of downtown Dallas is 1.5 centimeters to 300 meters. Find the actual distance between Union Station and the Dallas Public Library. Now remember, a proportion can actually contain measurements that have different units. So I can write the scale 1.5 centimeters to 300 meters as a ratio. Because the top is in centimeters, you're actually going to have to use a ruler and measure the distance from Union Station to Dallas Public Library. Now, if you did that, the distance is 6 centimeters. So then we want to find the actual distance, cross multiply, and you would actually get x equals 1,200 once you simplified it. So the actual distance, you could say, is 1,200 meters or 1.2 kilometers. Either answer would be acceptable. Now in example 3, we're going to make a scale drawing. The Lincoln Memorial in Washington, D.C. is approximately 57 meters long and 36 meters wide. Make a scale drawing of the base of the building using a scale of 1 centimeter to 15 meters. So we have to set up a proportion to find the length L and the width W. So let's, for example, set one up for the length. We know that our ratio is 1 centimeter to 15 meters. We know the actual length of the building is 57 meters, and we need to know what our scale model should be. So there's our formula to set up to find the length. Now, if you solve this, you're going to get 3.8 centimeters. We're going to do the same thing and the same ratio for the width, this should be fairly easy. And we would find the width as 2.4 centimeters. So then you would actually use a ruler. Now, I'm not using a ruler on the iPad here because I can't use my stylus against a ruler. You would then, if this is drawn to scale, which that is obviously not drawn to scale, you would use a ruler and measure out 2.4 centimeters as the width and 3.8 centimeters as the length. The next thing you're going to do with similar triangles is talk about similarity, perimeter, and area ratios. The perimeter and area ratios are probably new for you. So if you have two similar triangles, the similarity ratio is the fraction from one side to the next, the ratio of the sides. So for example, 5/10, 4/8, 3/6, the similarity ratio is 1/2. Pretty easy. Here's what is something you may have not done. The perimeter ratio is the exact same as the similarity ratio. So if you find the ratio of one side to the other, if you then find the perimeter of one triangle and the perimeter of the other, that is the same ratio as the sides. Now the area ratio is taken to the second power. So you take your answer for either one of these, and then you square it to give you the area ratio, which in this case is 1/4. Which leads into this, which we pretty much just explained. The comparison of the similarity ratio and the ratio of the perimeters and the area of similar triangles leads to the following theorem. If the similarity ratio of two similar figures is A over B, then the ratio of their perimeters is the exact same ratio A divided by B. And the ratio of their areas would be A squared to B squared, or by squaring the ratio A to B. Let's do our last example, number 4. Given that these two triangles are similar, we want to find the perimeter and area of triangle UVW. Right off the bat, we see that we have two sides. All we have to do is find the ratio of the sides. 16/20 would simplify into a ratio of 4/5. So this is the side ratio. And I don't like calling it the side, but it would actually be the similarity ratio. So this is the similarity ratio. Now the ratio of the perimeters is the exact same thing. So to find the perimeter, we would use the 4/5 equals, now the perimeter of the smaller one is 36, so we would write 36 over x, which would be the perimeter of the other triangle. So we cross multiply, 4x equals 180, divide, you would get the perimeter of triangle UVW. The perimeter is 45 feet. Now the area, instead of using 4/5, we are going to square it. So 4/5 squared gives us a ratio of 16/25. I then use the area of the smaller one, which is 48, and then I need to find the area of the bigger one. So that gives me 16A equals 1,200, and that would give me A as 75 squared feet. So we can use the ratio of the area and the perimeter to find the actual perimeter area of different shapes. The only two vocabulary words that I would expect you to know would be to know what an indirect measurement is and what scale means.